Hello, welcome back. This is a video over 4.6 notes, and this is applications of percent. And so what we're going to do is we're going to use what we learned in 4.4 and 4.5 to help us answer these questions. And these are going to be applied problems involving percent. We're also going to be talking about percent increase or percent decrease, okay? One thing that we can do here, guys, is we have to remember both of those formulas. Okay, so we have P times B is equal to A. So we have the percent of what is A, okay? And so remember that the period, or the multiplication symbol, stands for the word of, okay? So this is P, times B is equal to A, okay? And that's what we've got. So you can use that if you want, all right? Or you can use the proportion, okay? And that, remember, is part is over whole, which is of, okay? And that's equal to the percentage out of 100. So we can use either or. It kind of depends on what you guys want to do. It doesn't matter to me, but we got to be able to use both, okay? So let's read this first one, okay? And it says transportation to work, okay? So it says in the United States, there are about 154 million workers who are 16 years or older. Approximately 76.1% of these workers drive to work alone. So it wants to know how many workers drive to work alone. So let's translate this, okay? And I'm going to do both. I'm going to do P times B is equal to A, all right? First of all, they give us that 76.1% of these workers drive to work alone. So my P is 76.1%, okay? And so, on this it says that 76% of these workers, okay, so when I read this portion of the text, how many workers are there? There's 154 million workers, okay, so that's what's going to go down here. So I'm going to put 154 million workers is going to give us the percentage that drive to work alone, okay? So how many of them drive to work alone? All right, so I'm going to put an A here, okay? So the first thing I want to do, given this type of equation, is I want to turn this percentage into a decimal. So I'm going to take this decimal place, I'm going to move it over 2 units, okay? So that's going to give me 0.761 times 154 million, and that's going to equal A, okay? So I would need to do this on the calculator, so let me punch that in real quick. It's going to give me 117,194,000 workers, okay? And it's important that we, put those on a, put this answer into context. And so we've got 117,194,000 workers drive to work alone. Okay. All right, so I did this using the percent equation. Now I'm going to use this using my my proportion. Okay, so let's do this. Let's do part, and that's is over the whole, which is of, okay, and that's going to be equal to my percentage over 100. Okay, so our percentage was 76.1 over 100, okay, and then of, all right, and it says and this is a little bit trickier because it's not as easy to read, but it's this part here that says, of these workers, okay, how many workers are there? There's 154 million workers, okay, and that's where I'm getting that number, okay, and I don't want you to think that 76.1% is your of, okay, because it's not, all right. It says of these workers, all right. So let's come over here. I'm going to put down 154 million. Okay, I'm going to put an X up here, and then we're going to multiply, cross multiply, so I'm going to get 100x is equal to 76.1 times 154 million. Okay. All right. So 154 million. Okay, so if I do 76.1 times 154 million, 76.1 times 154, 1, 2, 3, 1, 2, 3. That's going to give me, and that's going to give me 11 billion, okay, 719,400,000, okay, and that's equal to 100x. So now I'm going to divide that by 100, but divide both sides by 100, and that's going to give us that x is equal to, we should get the same thing, which is 117,194,000, and that's workers. Okay, so it doesn't matter which way you do it, you're going to get the same thing. All right, so either one that you guys choose to do is fine with me as long as you're able to do it. Okay? All right, so then let's talk about percent increase and percent decrease. Now, I will say this, guys. All these problems require you to read them and understand them, which is a hard thing to do. However, it's something that requires practice and you spending time on it. Okay, so if you do spend time on it, you're going to run into problems, you're going to be frustrated, that's normal, but just keep working at it and you'll get it. Okay, all right, so let's look at percent increase. Okay, so I had to go ahead and change the problem that was already there because the one actually wasn't a question, it was more like a statement. Okay, so the percent increase, all right, let's take a look at this problem. It says the price of a car is $36,875, and then the price is increased by 4%. So we want to know how much is this increase, and then we want to know what is the new price. Okay, so, think about it. Things, if you notice how things get more expensive, they increase. And we can model that by showing by how much percent do those increase. All right, so let's take a look at this. We want to know, so the price of a car is $36,875. The price is increased by 4%. So how much was the increase? So what I want to know is, well, what's 4% of 36,875. So I'm going to do this. I'm going to do I'm going to do 4% and multiply it by 36,875. Okay. Now if I do 4%, that as a decimal is 0.04, and multiply that by 36,875. Okay, when I do that, all right, let's plug that in our calculators. 0.04 times 36,875 is going to give us a value of 1,475. And that's my value for A. Okay, this is how much we have increased. Okay, but I want to know, well, what's the new price? Okay, so the price of the car is not, $1,475. This is the amount increased. So amount increased, okay, and then if we want the total amount, all right, then what we want to do is we want to take 36,875 and add 1,475 to that. Okay, so let's do that real quick. 36875 plus 1475, and that gives us a total amount of 38,350. Okay, this is the new price. All right, and that's how that concept works of like percent increase. All right, so when things go up in price, we can model that by percent. All right, let's take a look at percent decrease. Okay, so for percent decrease, we have a similar situation. So when you buy the car, okay, the car depreciates in value, meaning that, you buy the car for this much, that's the most that the car is going to be worth. Okay, over time, the value of that car goes down. Now, this is a pretty steep value, going down 25% after 1 year. Seems like it, at least. And so what we want to know is, how much is the decrease. Okay. And so what I want to do is I want to take 25% of, so 25% of $36,875. Okay. So let's do move your decimal place over 2 points. So 0.25 times 36,875. And let's see what that is. And that's going to be 9,000. So $9,211.25. Okay, and this number represents the amount decreased. Okay, so this is the amount decreased. All right, now, and then it says what's the depreciated value of the car. So what I want to take the original price, which is $36,875, and then subtract off $9,211.25. Okay, and this will tell us how much the car is worth. All right, so I'm going to do 36875 minus 9211.25, and that's going to give us a value of $27,663.75. And this is the value of the car after 1 year. Okay? So this is kind of an interesting, way of looking at these types of problems. But, I just want you guys to, be able to go through this and think about it. This section requires you to think. It requires you to sit there, okay, what am I trying to find? What do we have? And notice how I was using this formula on these. Okay. You could still use the proportions if you wanted to, but I find it's just a little bit easier. It's less calculations I have to do when I do use my percent equation. Okay, so I want you guys to do 1 through 37, every other odd, and then do problem number 47. You will probably struggle on this section, and that's okay. I will make sure that I'm there to support you. Reach out to me, send me, emails and stuff like that if you guys have any questions. So I hope to hear from you. See you soon. Thanks. Bye.